Today we are going to solve this problem, sum of all odd rank subarray. So in this problem we are given an array and we have to find the sum of all subarray whose length is odd. Okay, and now what is subarray? A subarray means a continuous part of the array. So let's understand with example. If we have 1 4 2, okay, so subarray of all of this is 1 4 2, then 1 4 4 2 and 1 4 2. Okay, so see, but we cannot write 1 and 2 because it not a subarray, because 1 and 2 not 1 and 2 are not each other. Okay, 1 and 2 are not next to each other. Okay, see here there is 4. Okay, 1 and 2 are not next to each other, so 1 2 is not a subarray. Okay, now what those odd length means? See, odd numbers are 1 3 5 7 so on. Okay, now we only want subarray having length 1 3 5. Okay, so let's understand with example. See here, if we have array 1 4 2 5 3, see, let's list the odd length subarray. Okay, so in length 1 1 4, then 2 and 5 3. Okay, in length 3 1 4 2 7 and 4 2 5 11 2 5 3 is 10. Okay, in length 5 it's length 5. Okay, 1 4 2 2 5 3, it was 15. Now we add everything. See here, now we add everything. 1 plus 4 plus 2 plus 5 plus 3 plus 7 plus 11 plus 10 plus 15. Okay, so the total is 58. So the answer is 58. Okay, now let's take one more example. If we have array 1 2, so the possible subarrays are 1, length is 1, so it was odd, and next is 2, length is 1 odd, and 1 2 length is 2, so it was even. Okay, this is odd, they both are odd. Now see, we do not want 1 2, so we take this 1 plus 2 is 3, so the answer is 3. Okay, let's take one more example. We have array 10 11 12. Okay, odd length subarrays are 10 11 12. Okay, 12, so 10 plus 11 plus 12 is 33. Okay, 10 plus 10 plus 11 plus 12 plus 33 plus 33 plus, it was total 66. Okay, 66, so the answer is 66. Now see, how can we solve? So the first is brute force. So see, in the I will generate every subarray. We check whether its length is odd and add its sum. So that's what our previous is big O of n square. Okay, solution was doing, but in this LeetCode, in this program, see here, it is that. So but LeetCode asks, can you solve it in big O of n? So we need to think differently. Okay, so the important observation is, see, instead of asking what is the sum of every odd subarray, so let's ask, we can ask like this: when I reach a new element, what odd length subarray can create using this element? Okay, so this is the key. So let's understand with example. Let's take 1 4 2 5 3. Okay, suppose we are currently at 142. Okay, and current element is 2. So we want to know what odd length subarray are 2. So there are 1 4 2, both have, see here, 1 4 2. Okay, and 2. We want to know what odd length subarray end at 2. So there are this 2 and 1 4 2, both have odd length. So the sum is 2 plus 7 is 9. Okay, so for index 2, 0 1 2 3 4. Okay, so for index 2, the total sum of odd length subarray ending here is 9. Now look at the previous index. So before 2 we had 1 and 4. So what subarray end at 4? So odd length was 4 and 1 4. Okay, 4, then 5. Wait, 5, this is length 2 only. So see, 1 5, so this is length 2. Okay, so only 4. Odd sum is 4, even sum is 5. Okay, so this is even sum. Okay, now something interesting happened. See, when we add 2 previous even length subarray 1 and 4 and 2, 1 4 2, so the length change. Okay, 2 to 3, so even odd. Okay, so previous odd length subarray, so 4 we add 2, so it 4 and 2, so length will change like 1 to 2. So this is odd even. Okay, so that's the entire DP idea. So the main idea is, whenever we add a new element to a previous subarray, even length plus 1, okay, becomes odd length. Okay, it's become odd length, and odd length plus 1 become even length. Okay, so we only need to remember two things: odd sum and even sum. For odd sum and even sum for subarray ending at the previous index, so this is why we create two variables, odd and even. Okay, see, the standard DP formulation use f of I for the sum of odd length subarray ending at I, and g of I for even length 1. Okay, so let's understand with small example. So see here, we have array 1 4 2. Okay, so we start with 1, so subarray end at 1. So it's odd, so see here, odd is 1 and even is 0. Okay, now we add 4, so previous is 1, odd, and even is 0. So when we add 4, previous odd, current even. Okay, so 1 become 1 4. Okay, so our current even sum is 1 plus 4 is 5. So new single element subarray, solid Spanish. See here, 1 plus 5, wait, let me write here. We have array 1 4 2, and we start with 1, and odd is 1 and even is 0. So previous is this, where is this 4, so it's become 1 4. So new single element subarray 4, so is odd, so current odd sum is 4. Now even is 5. So now we add 2. Okay, odd is 4 and even is 5, so previous even plus 2, so it's 1 4 plus 2 become 1 4 2. So which is odd, its sum is 5 plus 2. 5 plus 2 is 7. So previous odd plus 4 plus 2 become, which is even its sum is 4 plus 2 is 6, and now new single element is 2, single element also 2, so it's odd, so current odd sub array are 2 1 4 2 is 7, so the odd sum is 2 plus 7 is 9, and current even sum is 4 plus 2 is 6. Okay, 9 6. So see, but where those this multiplication come from? Okay, now come the slightly tricky part. See, at index I there are multiple previous subarray of odd even length. We do not want to create all of them. We can calculate how many there are. Okay, suppose we are at index I, there are I plus 1. Okay, subarray ending at this index. For see here, so we are at index I plus 1 for every ending subarray ending at this index. For example, index 2, the subarray ending here. Okay, so the subarrays ending here 2 4 2 and 1 4 2, so there are 2, there are 1 2 3. Okay, there are 3, so their length are first one is odd, even, odd. Okay, so odd count is 2 and even is 1. Okay, for index I, number of odd length subarray is I divided by 2 plus 1. Number of even length subarray is I plus 1 divided by 2. Okay, because in C++ integer divisions remove the decimal part. So here see here, for example, 2 divided by 2 is 1, so and 3 divided by 2 is 1. Okay, now we can create the formula. See here, let's call f of I is equal to sum of odd length subarray ending at I, and g of I sum of all even length subarray ending at I. So to create an odd length subarray, we can take previous even length subarray plus current element. Okay, because even plus 1 is equal to odd, so f of I is equal to g of I plus current contribution of array of I. Okay, so how much those array of I contribute, it appears in every odd length subarray ending at I. So number of those I is divided by 2 plus 1, therefore see f of I is equal to g of I minus 1 plus array of I into array I of I divided by 2 plus 1. Okay, so these are the most important formula. Okay, so see, similar for even, to create an even subarray, previous odd length subarray plus current element, because odd plus 1 is even, so we g of I is equal to f of I minus 1 into array of I into I plus 1 divided by 2. Okay, so this is exactly the DP transaction used in the standard big of n solution. Okay, so let's try that. So let's take array 1 4 2 3 1 4 5 3. Okay, so we will maintain f is odd sum, g for even sum, and answer variable for final answer. Okay, final answer. So let's write down the index 0 1 2 3 4. Now I is equal to 0, I is here, so see here, array of 0 is 1, only subarray is 1. Okay, so it's odd, so let me write here f g answer. So f is 1, g is 0, and answer is 1. Okay, so now I is equal to 1, I comes here. So the current, see here, array of 1 is 4. Okay, so previous is f is 1 and odd is 1, even is 0. So let's calculate the formula. F of I is equal to g of I minus 1 plus array of I into I divided by 2 plus 1. So we put values here. F 0 plus 4 into 1 divided by 2 plus 1. So 1 divided by 2 is 0. So see here, f is 0 plus 4 into 1. So f is equal to 4. So that represent 4 is 4. Okay, so now we calculate even. G is equal to f of previous plus array of I into I plus 1 divided by 2. So G is equal to 1 plus 4 into 1 plus 1 and divided by 2. So G is equal to 1 plus 4 into 1. Now G is 5. Okay, so directly present, this will represent 1 and 4 is 5. Okay, so let's update here. Our f is 4 and G is 5. So the answer is 5 plus 4 is 5, 9. Okay, so the answer first is 1 and then 4. Now answer is 5. Okay, 1 plus 4 is 5. So I is, now let's I comes here at 2. Okay, I is 2. So array of 2 is 2. So previous f is 4 and G is 6. G is, I think, 5. Okay, sorry, G is 5. Okay, let's calculate odd. Okay, it's odd. F is G plus array of I into I divided by 2 plus 1. Then f is equal to 5 plus 2 into 2 divided by 2 plus 1. So f is equal to 5 plus 2 into 2. So f is equal to 9. Okay, why? Odd subarray ending at 2. So 2 and 1, 4, 2 is 7. Okay, so total is 2 plus 7 is 9. Now let's calculate even. G is equal to f previous plus array of I into I plus 1 divided by 2. So write down the numbers. G 4 plus 2 into 2 plus 1 divided by 2. So G is equal to 4 plus 2 into 1. So G is equal to 4, 6, 7. So 6. Okay, so G is 6. So that's here 4, 2 is 6. Okay, now answer. Now let's calculate the answer. See here, answer is 5. So 5 plus 9 is 14. Answer is 14. Okay, now our I comes here at index 3. Value is 5. I is 3. So array of 3 is 5. Oh sorry, it's Spanish. Previous G is 9 and even is 6. Odd, even. Okay, so let's calculate odd first. F of 6 plus 5 into 3 divided by 2 plus 1 and 3 is divided by 2 is 1. So f of 6 plus 5 is equal to 2. I think is equal to into 2. So f of 16. Then odd subarray ending at 5. So 5, 4, 2, 5 is level. Okay, now total is 16. So now even g is equal to 9 plus 5 into 3 plus 1 divided by 2. So g 9 plus 5 into 2, g is 19. Now answer, see, now let's calculate the answer. Where is answer? 14 plus 16 is 30. Okay, its answer is 30 now. Now our icons at index 4, last one. Okay, array of 4 is 3, and our, let's update this also. It was 16 and g was 19. Yes, g was 19 and f was 16. So odd, f of 19 plus 3 into 4 divided by 2 plus 1. So f 19 plus 3 into 3, so f is 28. Now odd, see, odd subarray ending at 3, 2, 5, 3, 10 and 1, 4, 2, 5, 3, 15. Okay, so the total is 3, 10, 15 is 28. Then 30 plus 28 is 58. Okay, so the answer is 58. Now that's all. Okay, it was very easy if you understand how these formulas are coming. Okay, now let's write the code from the idea. Okay, do not memorize the code, build it from the idea. So we said we need, see here, we said we need f of I means odd, length, array, sum, and g of I means even, length, subarray, sum. Okay, so first we write we want f and g, vector int f of n, vector int g of n. Okay, now we need the answer also. Int ans is equal to 0. Okay, so see, why do we start from index 0? Because index 0 is special for array of 1. Okay, so there is only one which is odd, so we write, see, f of 0 is equal to array of 0. Okay, then g of 0 is equal to 0. So and therefore, so the answer, let me create here, and the f of 0. Okay, so now the loop for int I is equal to 1, I is less than n, and then I plus plus. Okay, so why? Because index 0 is already initialized. Okay, here, so that's why we are going from index 1. Now we calculate the odd sum. See, in our idea said odd is equal to previous even plus current element. So and current element contribute array of I into I divided by 2 plus 1. Okay, so this is, so this we know. Okay, wait, let me write, f of I is equal to g of I minus 1, then plus array of I into I divided by 2 plus 1. So that's not a random formula. Okay, every part comes directly from our idea. So here this I g g of I minus 1, so it's the previous even length sum, okay, and array of I current element, and this how many odd length subarray ending at I contains this element. Okay, now let's calculate the even. So in our idea, even sum set, even is previous odd plus current element, so that we write g of I is equal to f of I minus 1, then plus array of I into I plus 1 divided by 2. Okay, so see again, f of I previous odd sum and array of I current element, and this number of even length subarray ending at I. Okay, then add current odd sum to answer. See, the problem has asked for sum of all odd length subarray, so and f of I contains the sum of odd length subarray ending at I, so we just write ans plus equal to f of I. Okay, so that's why we add f of I, not g of I. Okay, let's complete full code. Yeah, let me first initialize n, and n is equal to array dot size. Okay, see here, this line is f of I sum of all odd length subarray ending at index I, and this is g of I sum of all even length subarray ending at I. So this array of 0, see this okay, at index 0 only array of 0 exists, so its length is 1, which is odd. Okay, but see our answer is where is our answer? Wait. So this is also so f of 0, array of 0, so this is at index 0 only array of 0 exists, its length is 1, which is odd, and this answer, but our answer contained the sum of all odd length subarray. Okay, so f of 0, I just write this simply. Okay, let's first write this, then answer. Okay, now it's perfect. See, this line process the remaining element. Okay, it's process the remaining element, and this even length plus current element is equal to odd length. There are I divided by 2 plus 1 odd length subarray ending at index I. Okay, and this is odd length plus current element is equal to even length. Therefore I plus 1 divided by 2 even length subarray ending at index I. Okay, so in last add all odd length subarray sum ending at I, and in just as we just run the answer. Okay, oh, that's all. Let me run this code. Okay, see, instead of generating every subarray, I will process the element from left to right for every index, and I will maintain two values, the sum of all odd length subarray ending at this index and the sum of all even length subarray ending at this index. Okay, then the important observation is that when we add one new element and even length subarray become odd, and odd length subarray become even. Okay, so then, so see, the new odd sum become the previous even sum, and the new even sum become from the previous odd sum. Okay, we also add the current element or required numbers of time. So that's the whole idea. And see, the time complexity is, see here, this line. Okay, we traverse the array only once, so the time complexity is big of yeah, and we create two variables, and we have created two variables. We create two array of size n. Okay, two variables. So we have created two array of size n. Okay, that g, f and g. So the space complexity is big of n. So there is also a space optimized version where we keep only the previous odd even values, reducing space of big of n to 1, big of 1. So by keeping time at big of n. Okay, that's all. See, one thing I want you to remember, do not memorize this. Okay, do not even memorize this. Okay, memorize the reason, and do not memorize this, memorize the reason. So the reason is, see, even plus 1 is equal to odd, and odd plus 1 plus 1. Okay, plus 1 is even. Okay, and f of 5 is equal to odd subarray sum ending at I, g of I even subarray sum ending at I. Okay, see, once these two things are clear, the code become much easier to design instead of memorizing it. Okay, so that's all.